Hello again, and a warm welcome to our next speaker, Sander Hoogendoorn. Hi, Sander.
Hi.
Hi, we're happy to have you with us today, Sander. You have over 4 decades of coding experience, and yeah, besides being CTO at iBOOD, you are also an author, an architect and developer, and frequent speaker at conferences. So we are really looking forward to your promising talk, and I hope everyone will enjoy it. So see you later, and the stage is yours.
Thank you. So first of all, I hope that everybody can hear me. If not, let us know. It's good to be back at the ISAQB Architecture Gathering 2023 this year. Next year, we hope to be live again. And I'm actually probably going to do a workshop on the same topic I will be presenting today. So if you want to get more detail, it's also a workshop I do frequently. So if you want to know more, let me know, right? So it's a talk about, well, I call it microarchitecture. It's not so much microservices alone anymore. It's actually a whole lot of things together that you could try to achieve with, well, this architectural style, but everything that goes to it. And there's much more to it. And I'm going to try to give you this overview in about 45 minutes. So I think I should start with the most interesting stuff that most of us have been dealing with if you're a developer, and that is a thing called technical debt, or actually, as Ward Cunningham calls it, technical debt. So Ward says shipping first-time code is like going into debt. Right? It means that if you do a little development and every choice you make is a debate whether to go faster or add more quality, and there's a continuous struggle with that. And if you don't pay back that debt in refactoring your code and your architecture and your infrastructure, it'll bite you later. Word actually says that, well, if it goes really, really worse and you don't repay your debt, he actually says, well, entire engineering organizations can be brought to a standstill under the debt load of an unfactored implementation. And it doesn't matter what is the paradigm, whether you object-oriented or procedural or functional programming or just a website or whatever it be, you can come to a complete standstill. Now, unfortunately, I have had many clients that have had this situation over the years. And I'm going to give you a real life example from my own experience, which is actually the example for my current client. Now, my client is an e-commerce company, and this is the CEO and the CMO. They wanted to be in the slides, so I just added them to the slides. They like that. It is a fast-growing scale-up, actually, and it started 15 years ago with having a single deal on a website with an Excel spreadsheet, basically, to manage the stock and the orders and stuff like that. And they grow pretty rapidly. Actually, they have daily changing deals, so that gives them a sort of like unique perspective on stuff. So they grew their landscape over the 15 years that they've been alive, right? They had an old website and they tried to replace that website. They couldn't get rid of it fully. They had an app that wasn't released for like 2.5 years, and they had like blogs and forums, and then they had a lot of backend systems like an ERP system, a product information system, a CMS, an old CMS, a data warehouse, an Oracle system for handling claims, and a lot of smaller systems in place. And then they tried to switch to a microservices architecture. This is about 6-7 years ago, I would say, and they got stuck at the point when they landed at the most complex piece of the architecture, which is basically the checkout, which deals with reservations and orders and cancellations and all that stuff, which makes it highly complicated. So they also run it in the cloud. So there is, of course, a CDN. They have run it on different clouds before, and there's a whole lot of external parties that they send information to, that we get information from, like Voucherify, marketing tooling, payment providers, all sorts of parties in the landscape. And as a result of always being short of programmers, the data landed up anywhere, because at any point in time, any developers that they had, they picked on the tool that was basically the easiest to change at that point in time. As a result, they landed with all the customer accounts being in the CMS where they really don't belong, claims being everywhere, orders being everywhere, deals and offers being everywhere. And as a result, they needed to keep all that data in sync. Now, as you can imagine, if you do this for 15 years and you grow rapidly and even more rapidly, you come to the point that, well, maintaining your landscape, keeping it alive, basically solving the bugs, eats up so much of your time that there's no space anymore for real innovation. So as a result, their mobile app got totally stuck. They couldn't change their website. They couldn't change the backend architecture either. And they got totally frozen, basically. And then the question is, what do you do? Now, this is a scene from one of my favorite movies, right? This is where they escaped the fish tank in Finding Nemo to be out in the open sea in plastic bags. And they were like, now, okay, now where we go? So this is a good point in time to introduce myself a little bit more. My name is Sander, and in German it's probably pronounced Zander. And I'm a dad of three. I speak, I write, and I travel quite a bit. I love traveling. And you could basically call me a serial CTO, although I've been with my current client for over 3 years now. And I'm basically a lifelong programmer. I write code every day with my team, and I still love that very much. I've been doing that for over 40 years. So currently, I'm the CTO for this e-commerce company called iBOOD.com. It's also active in Germany, quite a lot actually. And I used to be the CTO for another few companies before that. So to illustrate that I'm actually a programmer, this is my name. It spells with double OO. So I'm basically double object oriented. To make it even worse, I live in the Java street in Amsterdam, which is not a joke. This is actually true. I also contribute to open source, by the way. A lot of the code examples that you see during this talk, if we're going to get to that point, are basically in the open source framework called Easy, which has an architecture for dealing with these landscapes. So a fair warning to start it off is that basically what I illustrate is the stuff that works for us. That does not necessarily mean it all works for you, but there's maybe stuff out there that you can use in your own experience, in your own situation, right? So the question is, how can you prevent technical debt? And there's only one answer to that, I think, and that is something that I start calling continuous renovation. This is my bicycle repair shop. This is my bicycle, by the way. And the thing is with most companies and most organizations that I enter or visit or I do audits on, is that they run into the same situation, is that where the renovation is really, really necessary because everything gets too complex, the shop always needs to stay open, right? You cannot close down an e-commerce company for a week or a month or 2 months because you're building something new. You need to stay open. And that puts a lot of strain on how you spend your time and what you do. So when it comes to complexity, I think Neil, who's actually speaking in one of the other rooms now, he has a great quote on that. And Neil says, developers are drawn to complexity like moths are to a flame, and often with the same result, right? We burn ourselves with complexity every day, and we all do this. I am continuous discussion with my teams about stuff, and we all make things more difficult than they actually need to be to solve the problem at hand. And if it gets worse, Gregor Hope has a nice quote on that. He says, well, excessive complexity is nature's punishment for organizations that are unable to make any decisions. Now, that is where you get right. At some point, you cannot choose anymore where to go. And there's only way out. And the only way out of that is to take really, really tiny steps. And I think John Gall formulated it quite well. John Gall says, well, if a complex system, if you have a complex system or a complex landscape as we have, that works, it's invariably found to have evolved from a simple system that worked, right? We started off somewhere and it still worked, and it grew and got more complex and more complex. And that is the only way to build systems, right? You cannot say, I have a complex system and I'm going to replace it big bang with a new very complex system because, well, basically nature is complex, right? That means you have to start over with a simple working system. And that means that you can only take small steps. And the question is, how do you do that? Well, I think for iBOOD and for a number of companies before, I came up with this interesting ideas about how to get out of this, which I'll briefly illustrate to you. So the only way out, if you have to take small steps and you don't know exactly where you're going, is to experiment, right? And experimentation is the only way out to renovate, to renovate continuously and still keep going. So I think it comes down to 4 parts. And these 4 parts are a concern to me, is you need to deliver smaller features, right? All big features, all big projects, delivering systems at once is too big and we just cannot deal with that. It disallows us from evolving continuously. That also means we need to go to shorter cycles than what, for instance, the current generation of agile approaches does, like work in sprints or iterations. We're going to move to shorter cycles. We're also going to do that with smaller teams. And I'll try to illustrate that too, because it's all part of, well, this bigger philosophy of how to move forward in these situations. And the fourth part is, of course, building it in smaller components. And in most cases, that means microservices. So I'm going to do the first 3 in a bit shorter, and the fourth part, I'll spend some more time on it. Well, let's go. So I'm going to get my glass of water. I poured myself some water just because I have a dry mouth. Let's start with the smaller features. The thing a lot of the companies that I start working for need to do is to identify the dot at the horizon. Why is that so important? It's because it gives you a direction to where you can experiment towards, right? In our case, in the iBOOD case, I'll give you the dotted direction that we are currently working on. And one of the important parts is the yellow part that says, well, basically, iBOOD is Europe's leading deal site. That has a lot of consequences for my tech department because, okay, we're going into Europe. That means we need to do more in more countries, meaning more languages, meaning opening shops in different countries and everything that comes with it. And a large part of that is due to how we innovate. It's also about our community, right? So we need to work on creating something for our community too. Or do that on a daily basis. We had daily changing deals, and they need to be more A-brand. Also, the A-branded deals brings a lot of direction because A-branded deals require an A-branded looking website. So we started on redesigning the website step by step too, right? So this is all following the dotted horizon. When you have identified the dotted horizon, you can start identifying the different types of work. We identified 3 types of work. We spend about 70% of our time as there's always more work than the time that we have available at tech. So 70% of our time we try to spend on stuff that helps us getting towards the dotted horizon. 20% of our time goes into features, adding small features into everything we have in production, including these days our newest platform. And 10% is just the daily bugs that you always have, but that you need to spend time on. So we try to keep this division in place. And getting that dotted direction together with the but sort of like the timing division that we have, make sure that we are always solving the right challenges. That means that, and this is a nice quote from Ewout Wolf, he says, well, basically, scalability is the number one problem we people don't actually have, but still solve. We, by the way, do have a scalability issue because we have sales and then we have 10 times more traffic than normal on our website. So there you go, right? It's 70% innovation, 20% renovation, and 10%, well, just for keeping the lights on. In order to get there, we need to decide. And to decide means we need to get the buy-in from everyone in the business. So we put up a tech board. And the tech board is actually to decide which items of work are we actually going to pick up and which ones are we going to leave behind. And we have a bunch of criteria for that. So first of all, we need to figure out if everything that comes in or anything that comes in, whether it helps us reach our goal. Right? If it helps us read the dot at the horizon. If not, we're just going to not spend time on it because we don't have the time available, right? The second thing is, and that's for us as tech to decide, is can we actually do this? Is this workable? Sometimes it's a good idea, but we cannot do this with the current technology. We know we're going to get there, so we put it eventually on a someday maybe column on the board. And the next step is, well, is it too big? If it's too big, we break it down. And we usually start by building the first step. We are now going to re-implement how we deal with stock. And the first step is creating stock per product. which sounds normal, but we don't have that currently. And that is the first part of a bigger thing, right? And the next thing is we are only going to spend time on the ones that are the most urgent and important, right? Meaning, do we really need this now? If not, we can do it later, and we do the important stuff first. This morning, for instance, we decided in the tech board to not implement a new API from our payment providers because, well, we don't need it yet. And moving content from the old platform to the new platform is much more vital to us. And then there's the Sunday maybe column that helps us, get through words where we need to be. So this helps us basically to focus and spending the time on the stuff that we really, really need to do. So in the 70% of the time, we build up the whole new platform. And it's been taking 3 years so far. A lot of it has already been in production, and we started basically grounds up with a very, very small thing first. So the next step we discovered is that if you go to more shorter cycles, even shorter than having iterations, you get more rapid feedback. We all know that, but it has a lot of consequences on how you build your software. And microservice is an excellent architectural style if you want to go into shorter cycles, meaning getting faster feedback and being able to maneuver much faster. So how do you do that? Well, basically, as I said, you get more rapid feedback. You try to shorten the cycles. In a historic perspective, I've been in this industry for 40 years plus. So that means we went from a single cycle in the waterfall era right into in the 90s, we had cycles of 4 to 6 months. And you see that DSDM came along and other approaches. And we went to 4 to 6 weeks. And then the agile approaches like Scrum and XP came. And we went to 2-week iterations. And people thought, oh, that's really short. Yes, that was really short 20 years ago. It's not short these days anymore. I actually recommend a lot more people to actually drop the whole sprint idea because it basically saves your work and you can go much faster if you want to. So we actually started doing continuous delivery and even better continuous deployment, meaning automatic deployment to production when all the tests run green. I'm actually at the point of checking in my code. I just couldn't make it before I started this talk. Otherwise, it would be out now in the pipeline, going all the way to production if nothing stops it automatically, right? So you need to automate everything. And the nice thing about it is that, if you go to deliver value continuously, and we actually go to production with my team about, I would say 30 to 40 times per day, that means that the landscape is continuously evolving in small changes. Sometimes people don't even notice it. And sometimes there's slightly bigger features that we push out. And the nice thing is, the more often you release stuff, the better you get at it. It's not that if you wait longer that it becomes easy. It actually doesn't. And Jess Humble says it really right? He's the author of the Continuous Delivery book, or one of the authors, Dave Farley being the other. And he says, if it hurts, do it more frequently. Meaning, if you have trouble releasing stuff, by doing it more often, you can recognize the pain of it, right? The pain we currently have is that the people in the business are slower than we are, which is an interesting problem for us because that has never been that way, right? We are now waiting for people to actually test the software basically in production that we've built, and we put it in feature flags, of course, with that. So here's the deal. If you release, let's say, once per quarter, the number of changes that you're going to try to release to a next release of your software is pretty big, right? Represented in the red arrow. And if it's pretty big, that means it's more complex to release. So the longer you wait, the bigger the complexity becomes. And the bigger the complexity, the longer it takes for you to test it in production and in collaboration with all the other systems. So that means if you're going slow, the result will be that over time you will get slower and slower. I've actually worked with organizations that got so slow that they could only release one release per year maximum, right? So if you're a product selling company, you're basically doomed. So here's the thing. It's the dependencies that will kill you. So you need to break free from those dependencies. And again, microservice is a great help in getting rid of these dependencies, because if you split up your landscape in a lot of small moving parts, what will actually happen is that you can start releasing iterations of these individual, let's call it services for now, that have so few changes that getting to a new version of it is actually very little work. That is, if you test everything automatically, because you always need the vertical slice through your current live services to actually make sure that you can test the whole integration and the whole system. And we'll get to testing in a sec. So this is the thing, right? This is where you need to go. You need to go to smaller stuff that you continuously release. In order to get there, you need to do two things. That is, you need to automate everything. And the second is you need to start testing from day one. And you need to test everything automatically. Manual testing slows you down. So let's start with the automation. So Jedward Deming said it really right. He said, well, you need to cease dependence on inspection to achieve quality, right? Everything that you inspect afterwards, and that includes code reviews, pull requests, peer reviews, all that stuff is always later than it necessarily has to be. He says, well, you need to get the quality into the system itself instead of checking it afterwards. That gains speed, right? So that means you need to invest in full CI/CD. Now, this is a picture of one of our current pipelines of one of our services. When we push it to the pipeline, it actually starts on the left side with building format and linting. Then it runs all the automated tests, and eventually, and I'll show you more a bit when we talk about testing, it actually gets to the end. And as soon as it reaches the end, it actually is in production. And we do this all the time, right? And it means also your infrastructure needs to become code, because you don't want to have to do anything manual on our infrastructure. We actually rarely or even never touch our infrastructure. And if we do, we change it in code, meaning all the pipelines go again. All our infrastructure in the cloud goes again. Our databases come back up. They scale automatically. That is stuff you can all automate. You shouldn't have to do this yourself. And that includes stuff like Kubernetes configuration. If you do that, please leave it to the actual cloud providers, because they're much better at it than we are. The second prerequisite to this is that you start testing from day one. So if you're used to do a lot of manual testing and you have very little unit tests, very little automated tests, it actually slows you down, because you have to wait every time until all the tests have run. And if you want to go to production 30, 40 times per day, you just cannot have this, right? So you need to turn around this whole pyramid. You need to have everything unit tested. All your APIs on your microservices, you need to have them tested as well automatically. And you need to trust through the scenarios, whether that is processes that you execute, whether that's going through your website, everything needs to be automated, right? And it starts with the unit test. Michael Faddis has a nice quote on this. He says, well, basically, unit tests run in isolation. And the reason for having them run in isolation means they can go quicker, because if you have thousands of these unit tests that you need to test and go through every time you deploy something or you put something through the pipeline, it is really time consuming. That's why you need to be able to run them in parallel. And that is why you need to isolate your unit tests. But the thing is, basically, a large part of our automated pipelines is actually testing. And I'll show you all the different test types that we currently do, right? So it starts, for instance, let's see if I can point this out. So it starts with unit testing before it even goes to our test environment. We do syntax validation, linting, formatting. It all goes through the pipeline. Then we do static code analysis. Then we publish it actually to our test environment. This is where we run the API test. So we deploy it to dev, we package it, and we deploy it to dev. Then we run the API test, and we run the security test and the integration test. We deploy it to our acceptance environment. That is where we run our web test and our performance and load test. And then we push it to production. And sometimes we need to bootstrap stuff. This is actually going on in between. And then we still run end-to-end tests every 5 minutes on our platform. And the only reason, well, the most important reason for us to do this is so that we can actually code with confidence. And we don't have to pray for our code to work, right? So this is, of course, this developer is praying, well, because he works in light mode, and as a developer, you just don't do that. So third part of the equation, this is actually teams. And if you're talking about teams, the problem with software development is that software development is actually extremely complex, and it gets more complex by the day. Luckily, we have now AI to help us out, right? So this is Etske Dijkstra, and he says that the programmer has to be able to think in terms of conceptual hierarchies that are much deeper than a single mind ever needed to face before. He's actually right. So this is the tech stack of one of my previous clients. They went bankrupt, by the way. This is unmaintainable, right? There is so much in here that the team of 30 to 40 people that were maintaining this tech, they just couldn't do it. And the company went bankrupt. So the only thing I see when I see this really complex tech stack is that there's lots that I don't know. And that means that we need to let go of the idea that we can work with individual people that can build all this software. That doesn't exist anymore. The smallest unit of work in software development is the team, right? And Charity Major says, well, she actually says that, right? And well, it's the team, right? This is where it all goes on. I'll show you my team just for a sec. This is a part of my team. This is our office. It's pretty messy actually, and this is just pictures years old where we just got our Christmas presents. And the one thing I realized is because we don't have hundreds and hundreds of people, that means we need to let go of multiple stacks. So we are slowly moving towards a single stack. In our case, it's a TypeScript stack with React and Node and React Native slowly that will come too. And the MongoDB database bases actually and running on the Google Cloud. It's the single stack that allows us to do stuff. If we needed to maintain multiple stacks, our knowledge would become too fragmented. So we move towards a single stack. And we only focus on solving a single problem every day. And those problems come off the tech board, right? And then we decide how to do it and what to do with it. And the nice thing is, we don't have to work with the whole team on every item. You can actually do multiple things at the same time because, well, they just require different skills. And we saw that we were moving in the direction of what I started calling years ago micro teams, is that every day when we start to pick up something new, we pick an item, we form a team, small team, 1, 2, 3 people. We discuss the work, do the work. We report it as done, usually on the same day or within 1 or 2 or maybe 3 days. We disband the team and we repeat it. And we do that in different settings, right? It changes all the time. Just to give you some examples, this is a developer and an operations guy working together on some infrastructure. Here you see 3 developers on my team. In this case, it's 2 backend developers and a front-end developer, or actually they do all 3. Here you see 2 developers and a tester. Of course, the tester has to stand, right? That's what they're for. And here you see an architect and the developer. Typically, the architect is praying for the code to work, and the developer already knows, well, might not be the case, right? So this is how we roll, right? We continuously work in different settings with different people. I work with different people every day on my team, which is pretty cool. But it also helps moving towards bringing it down to smaller components. Now, here's the question is, right? You see a lot of people talking about microservices these days, and then there's the news that like Amazon Prime throws AWS servers under the bus, right? And everybody says, no, you shouldn't do microservices. Microservices are dead. Let's go back to the monolith and death of microservices, and it goes on and on and on, right? This is basically the hype cycle. I think the best quote comes from Tim Davidson. He says, well, microservices are not dead. And they continue to be a viable approach for many businesses. However, you also need to take into account that there's lots of drawbacks from this architectural style, just as there is for other architectural styles. So you need to find whether it fits the problem you have. In our case, we need to renovate and keep the old system alive. So we need to move piece by piece. And there, microservices is an excellent choice, especially because we also have scalability issues. So the conclusion actually is there are no best architectural practices. They just don't exist. At best, you can say, well, there's good practices, but they're also only valid within their own context, right? There is no best practice that is valid everywhere. Some of the better practices that I've seen over the past 40, 50 years deal with high coupling and low cohesion, as or the other way around, which means that you put together stuff that belongs together. That is not about layers. That is about the subject, the part of the domain that you work in, right? So put everything of a single domain together, or a subdomain or a bounded context, put that together. And Unix does basically the same, right? They write programs that do one thing and do that one thing really well. And if you go into Agile Software Development by Bob Martin, for instance, the book where he points to the solid principles, the single responsibility principle in there also points into the same direction, right? And that goes from really big chunks like systems to modules to services to actually functions even. He says, well, every modules should have the responsibility for only one thing and do that one thing really well. And that is how you start breaking up stuff. Like, for instance, in code bases, if you have a file with 352 lines of Python code, it's probably doing too much at the same time. So that's where you move into microservices and a microarchitecture, I would say. In this architectural style, and I give you a definition of that, there's actually most of the topics that I just passed on come into play here, right? It's about automated testing. It's about infrastructure as code. It's about working in small teams, delivering all the time, right? And this is what it comes down to. And in this definition, the short definition, fileless is basically the same. But for me, the key point in this definition, there's two actually. It's basically stuff that is running in their own process and communicating with lightweight mechanisms. So basically running in their own process allows us to deploy different versions of small parts of your system all the time, right? Because the smaller the changes get, the easier you can deploy them. And this is one of the big benefits of running into really small components in your landscape. And they all need to be built around business capabilities. Now, once you move in that direction, you get to get into the domain of domain-driven design. And domain-driven design is actually a very good paradigm to start identifying and modeling your services. So to point in that direction, this is what Eric Evans says, right? He starts with the bounded context. Now, the bounded context, for me, when I started doing microservices in late 2013, actually, when they were just barely invented, I started looking into the bounded context pattern in Eric's book. And he says, well, if you have large domains, you always try to create this single unified model, right? You all remember the very big database models that you have. If you do that, every change to that model is actually making it brittle and fragile, because one change can result in stuff breaking on the other side of your landscape, and that you need to try to avoid. So here's what you could do, right? If you have this single unified domain model, look at the bounded context. And a bounded context to me, and there's different people talking in different directions, but it's all quite similar, is when you can say every item in the domain and every concept in the domain has a single meaning. This model typically hasn't, right? Because there's a product that sits in delivery of orders and there's a product that sits in replenishment of your stock. This is actually a real life example that I could actually give you now. But so this here is a good example. Product actually consists of two parts. If you split those up, then the world becomes a lot more clearer. And the thin line here is exactly with a high cohesion and low coupling, right? So everything on orders is on one side and everything on replenishing stock is on the other side, and they're very thinly connected. So this is the first step in breaking it down. The second step goes into the aggregate pattern. Now, the aggregate pattern basically says, if you have a group of things that belong together, usually demarcated by a boundary where you sort of store everything at the same time. Traditionally, you would do that in a transaction, but databases we currently work for don't even have transactions anymore. But it's still the stuff that you want to store wherever you store it, right? Whether that's in Salesforce or in a database or in Oracle or whatever you do. If that is the unit of work, that's sort of like your aggregate. Now, in the book, and remember, this book was written way before microservices were there. He says, well, every aggregate has a root, and that root is an entity. So, for instance, if we have the order aggregate, it has the order class as its root. So we enter to the aggregate by that particular class. So the ID of that class is the identifier for your aggregate, and that's when you see it. And graphically put, you can have larger bounded context. And within these bounded contexts, you could say, well, maybe there's a whole bunch of these aggregates. And the nice thing is these aggregates map exactly right for us, and remember, just for us, to the services that we're trying to build. So we put all of them in there. And now the next step is that, and that's why I talk about micro architecture, is that it's not just the backend services where you can do this and make them a lot more independently deployable. It's the same for the applications as well. So I'll give you the example. And quite coincidentally, this is also an example from a web shop, although I built this slide deck way before I was the CTO for an e-commerce company. It is actually an e-commerce example. So if you consider, let's say you've already broken down your backend services into separate services, then what I see a lot of companies do is they have still this big monolithical application that, yes, it now talks to the services, but it's still all connected, which means it's still not independently deployable in small parts because the website keeps everything connected anyway, right? So the next step would be to also break up those. And then I started realizing, okay, I can do that too. So if you start identifying that it's not just an application maintaining data, but it's a landscape that implements business processes, then you can go a long way. So that's what we started doing. To give you an example, right, you go to a website, you select a product, or you select another product, right? You put it in a cart. So you need to show the cart, and then you want to go to the checkout, which is usually a different page on most websites, in our website actually as well. And sometimes you need to register as a customer, which is part of the checkout or not. You need to register your payment, usually with a payment provider, and eventually you will show the order in the overview, and you will just commit to it. Now, the nice thing is we all see this, right? And we all know this. But if these individual parts talk to the services, they will all talk to one or more of these services. So the actual domain of each individual steps in the process is a little bit different than saying it's just connected to one specific service, right? So, for instance, to show the order in overview, you need to show somebody's profile, the order items, the products, the prices, the data about the shipment. So you go to the shipper service, etc., etc. And then we figured out, what if we put this in small applications? So if you would literally go to the iBOOD.com website, iBOOD website.com website, you can actually see this in action, because in the URLs, you can actually see, if you go, for instance, from the website into your profile, you go to the Profiles app. And if you register a claim, you go to the Claims app. And if you change stuff about your account, you go to the Accounts app. So we have made these really small, and the basket is a different app than actually the website. And we do that because then they can also be independently deployed. And they also have their own small aggregate that they deal with. However, in this case, they don't store it to a database, but they store it to a bunch of services, right? So that's allows us, we now have about 20 to 25 different apps. Not all of them are visible from the outside, but a lot of them are also on the inside or for suppliers, etc., etc. So we've broken that up too. And the nice thing is, because we have a fairly small team, and by now we have like 125 different code bases, all of these code bases have the same internal architecture. And that is an interesting part. And the nice thing is, I brought this architecture along, and it's been with me for over 20 years. And I use it every time, not because it's the best one. It's an architecture. Remember, if it works for us, it doesn't necessarily work for you. At any element in our system, every service, every app have the same buildup, right? There's the domain layer where the entities sit, and the value objects and the enums that make part of the aggregate of this particular domain. Around it, you could say the second part of the domain being the repositories. And repositories are classes that help you get through to the entities, right? They help you solve it and save it and get and query and stuff like that. It's a typical pattern from the domain-driven design book. On top of that, we use use cases. Use cases for us steer all the business logic, the process logic in there. And there's actually quite a lot of process logic that does not belong in a particular repository. They also allow us to do easy authentication and authorization. If it's a service, then it has a service interface, right? This contains the endpoints to which we can reach the service. And on the bottom, it goes out to wherever it needs to get data from. It could be from a database, it could be from another system, it could be from a bucket, it could be from Firebase or any other authentication mechanism. So we go out of the service in a bunch of different. It could also be that you go to other services in the same landscape. So that's what the gateways do. And the gateways are basically our data layer. The funny thing is, this architecture has stuck with me for quite a long time. This is a code base that I dug up when I was still working for Capgemini. It has the same architecture. It has a data layer, a domain layer, it has a process layer, and then there's the web pages on top of it. And also the way we implement these repos has stuck along with us for quite some time, right? This is a quick example. You can see the code later on, right? This is an example of a repository class in C#, which I wrote in 2008. Here's one in Java from an insurance company that I was the CTO for. It's a functional style of Java, so it's not regular Java, right? It's slightly more advanced. Here's one in Python, actually, from my current client when I started here. And here's one in TypeScript, which is our current stack. And this is one actually from this is the one from our shop service, actually. So, and that's why you can see this, that it's the same architecture all along. Well, if you have a small team and you have so many repos, and this is just a part of the list of our repos, and it has grown a lot since I took this screenshot, and you need to maintain all of these code bases. You need to be able to get into any of them and look into the code. You need to be able to read it because it might not be your own code, right? That means that having this single architecture really helps. Okay, so one small step more, and that is the next step that is still solid and fixed together and keeping you from distributing stuff is the data, right? So traditionally, if you have a monolithical application, you have one big database that sits under your application. And what I see people do is then they start to split up this application in services, but they still stick to the same database. It's the same Andy pattern that you would have with the application, right? If you still have a single database, everything is still tied together. You can still not deploy one of your services without actually touching the other ones because they all touch on the same database. So eventually, you'll get to the point where you do this, where you say every service has its own data storage. And the nice thing about that is then you can now go into like a polyglot persistence where any service that you might have picks out its own type of storage, right? For instance, the claims that I would go into in a claim system, it's an Oracle system. Our accounts and authorization go into Firebase, which is Google Cloud. Order goes into MongoDB database, and our products actually come from a Postgres database, right? So they have different storage mechanisms. And you can do this because the boundary of your aggregates sits in the service. That means you only store everything that's inside of your service at once. So that's an interesting part. So one last thing that I really need to dig into is, well, I already discussed it briefly, is the part where you need to go into automating your stuff and do continuous delivery. So the continuous deployment means that you have pipelines. So pipelines are running for all of your services and all of your apps and even all of your data changes. So in our case, every repository, whether that's an app or whether that's a service or even the small set of libraries that we maintain as well, have their own pipeline. So next to having 125 repos, we have 125 pipelines. They are modeled as a pipeline template in code, of course, in Terraform. And that means that if I want to change the pipeline, I'm not going to change one of them. I change the template and all of them change, right? If we add steps, so we recently added steps to do more rigorous dependency checking during the pipeline, because, well, there might be broken dependencies in the landscape, right? It is NPM, right? So it's a large package management system, and there might be breaking changes there, right? So we need to check that all the time. So we add stuff to the pipeline more and more. It gets longer and longer, by the way, and it takes longer to run. I think currently our normal pipelines run about 7 to 10 minutes. So every one of these has their own pipeline. All of these pipelines, so one per service and one for each of the apps, and they're all automated in Terraform, right? We don't do anything by hand anymore, and we don't even touch it anymore. It's just there. We extend it every now and then, and that's it. So the nice thing about it is that everything that we put together is basically helping us to do this, right? To solve small problems with a small amount of people in a much shorter cycle than you would do if you do it traditional agile. So we release stuff to production all the time, and with my team, which is now 13 people, we can actually handle a full e-commerce company, which is actually quite interesting to see. So short repo because I only have like 2 minutes left. This is it, right? If you run into stuff like technical debt, you cannot get away from technical debt. You need to move towards this era of like continuous renovation. Keep the shop open, change small features on your existing systems to keep people happy, and spend a lot of time on doing the innovation and start from scratch and start really, really small. And the only way to do this is to actually build small features, right? Do not try to build the big system or even the big module or even really big services, as in microservice or what. Just keep it small and build small stuff. And you do that in shorter cycles, meaning make sure that you can shorten your cycles all the time, because the shorter they are, the more rapid you get feedback, not only from your users, but also from the pipelines themselves, or also from other people working with your code. And then you can go to smaller teams. Smaller teams means also shorter cycles because there's less overhead. And then you can build all this microservices architecture, right? And bear in mind that if you do that, you need to automate everything. It helps to set up a reference architecture like we did. Doesn't have to be ours. It could be any reference architecture, just as long as you keep it simple enough so people can go into the code and all recognize each other's code. And you need to test it automatically, of course. And be sure to separate the data, and be sure to separate your application as well, because, well, everything that keeps the dependents together, it slows you down basically in releasing more often. So that's basically it. And that's the way we do solve small problems every day. And I'm currently rebuilding our menu, actually, so I need to check that in today so we can actually see it on the website tomorrow. There's only one thing you need to do, by the way, in this era, or actually two things. That is, you can never, ever, ever stop learning in this industry, because this industry goes so fast that the current knowledge you have will be outdated within 3 years, literally. A lot of research has been gone into. And still, it's the industry that is the most fun, right? I haven't been in this industry for 45 years if it wasn't the most fun there is. I wouldn't know what to do with my life other way, actually. I like writing code. So that is it. I hope you, unfortunately, cannot see the audience, but I hope you enjoyed the presentation. If you have more questions or if you want to know more, I'm actually working on a book on the first 3 parts out of the 4, which hopefully is going to be called Unstuck. After that, or maybe even in parallel, I'm going to start up writing a book about microarchitecture. So bear with me, and hopefully next year, one of the two either will be here. Also, I run workshops on this stuff, and I'm hoping to do next year, November 2024, to do the workshop in Berlin at the ISAQB gathering when it's in person again. So thank you very much. If you have more questions, this is my reference data. Follow me on LinkedIn. I'm easy to find on Twitter too. And thank you very much for being here.
Thank you so much, Zander, for this excellent talk and for sharing your thoughts and experience. We have some questions from the audience, so let's start with the first one. How can we overcome the issue of reduced development speed caused by the implementation of complex automated tests in our application testing process?
Yeah. Again, it's the same philosophy. If you have large and complex automated tests, if your tests are hard to change, that is an indication, a strong indication that your code is also highly complex. So whenever you have that situation, you need to go back and start at the bottom, right? Start small, pick one isolated block, start testing there, and work your way up. It's, I think, still a lot better to have a lot of small tests that are easy to change because they're small, than to have less but way more complex tests because they're harder to change. And the problem with them is that they also, as soon as you change anything in your code, especially when it comes to front end, your tests quite often break while the software is actually still working, right? So I would recommend going back into the lower levels of your testing pyramid and write a lot more smaller tests so that you're actually assured that those work. To give you one example on this is our open source project called Easy. I think we have running about 1,800 tests on those. And they're all small unit tests and a few integration tests. And the good thing about that is if I make a change to that code base, I know that it will work because, well, almost always will work. There's no guarantee, right? Because we have all these really small tests running on everything. So everything I start adding from now on, if you're starting from an existing code base, just everything you do that you touch right now, put it into a test. And if that test is hard to write, it's because your code is too complex. And then you start to break down on the complexity of your code while you're writing the test for it.
Great. Thank you for this answer. The next one is not really relevant to the talk, more kind of a personal question. How do you, as a CTO, stay or try to keep up to date with even your simplified tech tasks?
By doing it. So, so the nice thing is, right? So the tech board I earlier discussed, where we set the direction and where we're going. That's where the big chunks of work come from, right? And I'm as much part of the team as the rest of the people on the team. So I write as much code as the other people do. The nice thing is we all have our preferences, right? I love working on our frameworks, which I do a lot. And in a sense, we all contribute, usually in different ways, because everybody has their own specialty, right? There's people who are much better at UI than I am. There's people who are much better in backend or database stuff or infrastructure than I am, but I'm better at writing frameworks, right? So we all get to pick. So the team is fully autonomous. That means everybody picks the work that they want to do. For instance, I had a discussion earlier this afternoon with one of my female developers, and she said, "Well, should I pick up the changes in our CMS system, or should I work on the movers that were moving offer content?" Or there was a third option, and I said, "Well, what do you like best to do?" And she said, "Well, I think I like this one best." Well, pick that one up, because those are already voted to be the most important ones. And the only thing to do is, if you want to keep up with the technology and with writing code, is do it. There's no other way. So every job I take is basically one of the first questions I ask is, or I say is actually, if you want to hire me, I can help you solve your problems, but I am going to write code. And then what you sometimes see is that CEOs and COOs of companies say, "But yeah, you're much too expensive to write code." And then I usually reply is, "Wait until you hire a cheap programmer. That's much more expensive." So yeah, there's the only one way of doing this. Do it.
Great, yes.
And it's the one thing I enjoy the most, right? Writing code with my team. I love that. That helps.
Okay, great. Let's jump to the next question. What is meant by the term object in the context of DDD and microservices? Object in the sense of the object-oriented paradigm? If so, what about projects that use the functional paradigm?
Well, to be honest, there is no in DDD. There's no such thing as an object. There's called an entity that is not necessarily a class. It can be. It depends on what paradigm you're following. So, in I can only speak for our platform, right? So every component, every service, every app has its own domain, its own aggregate, basically, which usually exists of a number of entities. In our case, those are classes. We're writing TypeScript that have features. The functional part of our system is, well, everything we do is actually functional. Is more about the handling of that object. So the entities are immutable by nature. That means the only change they have is when they change state, which means I get actually a new instance of the class. And that state is changed along executing a process, which is highly functional. We have to have, by the way, only functional code because everything is asynchronous, because otherwise microservices landscapes do not perform. And because everything is asynchronous, we write it in a functional style. But yes, we do still have entities, and those entities are classes. And they, yeah, what can I say more about it? They're always the heart of every application that we build or every service that we build. They do validation, so we can validate an entity or a list of entities, and that's the thing that we're going to save. But the entity is usually an aggregate, and then we save the whole aggregate at once. We can do that because we use Mongo as a database, so we can just push in the whole JSON for the whole aggregate. But yeah, there's still entities in our view, right? So it's not that in a more functional style of programming, there's no more entities, not necessarily, but it's far less object oriented. It's more about the state changes that are caused by events that fire.
Okay,
I hope
thank
that
you.
is a bit clear. But otherwise, if my replies are unclear or I talk too much, connecting to me on LinkedIn is really easy, and then I can answer much more elaborately on it. But
This is good. Thank you so much. We have two more questions.
yep.
With separate databases for separate concepts, how difficult is it to make sure that the data doesn't have dependency between them? If different databases need to get data from each other, how do you tackle those? An orchestration layer that abstracts all the different DB languages? What do you ensure transactionality?
So typically, if you build services that are aggregates, so by definition, an aggregate, if you look in the definition that Eric Evans gives of it, an aggregate is basically the unit that you store. So in a traditional relational database, which we don't have, by the way, yeah, we do have them, but only in our legacy systems. The aggregate of a service is stored as a whole to the database, right? So that guarantees transactional integrity for that particular aggregate. It doesn't for the other aggregates, of course, right? So we try to avoid, and there are lots of different mechanisms that you can apply for this, but we try to avoid going over these boundaries, right? So every service as such is a boundary. That means if a service needs data from another service, it does not go into the database of the other service. We don't do that actually. So what you need to do, if you're the order service and you need to get the offer that I'm actually buying, the deal that I'm buying, I go to the offer service. I get the offer out, and we usually do as much as we can service to service, right? So we basically, what is a good example? So if we get a whole offer, so an offer in our case exists of offer items. Items have products. Products have content. They have descriptions. The offer items content, and then there's stock information. That whole thing is basically what we need on one of the particular pages on the website, which is called the PDP, so the product detail page. That's the only place where we need it. So we get out as less information as we can on all the other pages, and that's the only page that we do full blow up. But that is, again, only services talking to each other. The services themselves do not have access to the data of other services. Literally, they don't. And you need to guard that boundary, because otherwise you get into dependencies again. So that means you get them together at a higher level. And then the discussion you always go into, yeah, but that's eating performance. Well, yes and no. So that means that you need to do different things to manage the performance than you would do on a monolithical database. And then again, right, there's no right or wrong here. It's like if a monolithical application works best for your situation, do that, right? That's really good. If, on the other hand, you need to evolve, where part of your landscape evolves so rapidly while another part revolves really slowly, then breaking it up into smaller parts, into microservices, is a more viable strategy, right? But that works best if you break everything up, right? So that is data separately, services separately, apps broken up into smaller apps. And even we have a lot of things that we call workers that are basically consuming events. They have the same architecture and they've only got a single task as well. They also have their own domain, and they usually borrow from services. So that's the how it sits together. So no, data is not shared through services, and we
Great,
have
thank you.
been able to avoid that for 3 years on a let's say successfully running platform. So I don't think we're ever going to go into this direction.
Okay, yeah, let's jump to the last question.
Mm-hmm.
What is the most important reason why you want people to understand the code architecture of other teams?
Sorry, I didn't get the question.
What is the most important reason why you want people to understand the code/architecture of other teams?
Of other teams.
Yes.
I still, I'm sorry, I still don't understand. I don't now. I don't understand the question. Like, so the code of other teams. Oh, as in, well, I think I understand it. So we have over 125 small repos that each of them cover either a small app, a small service, or a worker, and so we have way more services than we have people on the teams. That means that it's not where very large companies usually have a single team being responsible for a number of small or services, but nobody owns all of them. We just cannot do that in this situation. So we are in a situation where we have more services than people, right? So that means we act as one single team, and we're responsible for all 125, which means I need to be able to go in any of these 125 repositories and change the code. I can only do that if they all follow the same architectural patterns. If I have to identify and figure out how a particular service is built because somebody else builds it who has a very different style, then that takes way too much time, right? So the architectural or the internal architecture of each of these repos is the same, because I need to be able to go, any one of on our team needs to be able to go into any one of these repos and do work almost immediately, right? The thing is, you should spend time on understanding the domain of that particular service, which you don't always know by 100%, but not the technology, right? The technology should be clear. That's why, and so we do this because we have less people than services.
Okay. Xander, one more question came up. Is it okay for you to answer one more?
Yeah, sure. Yeah.
Okay. If you don't have sprints, how do you get requirements and plan features and tasks?
Well, okay. So this this is a sprints is a topic I debate quite a lot, actually. So I started doing sprints. I think about in 2014 when I was doing my first microservices project. And the thing is, so why would you restrict to doing mini projects, because sprints are mini projects where you set exactly what you're going to do at the start of the sprint and then hope to deliver that, which you, by the way, never do, because either you don't estimate quite well, or you're done early or done late, or people add stuff to it. So it starts shifting again, and it sort of adds to a culture of failure, right? So where people say, oh, we didn't make the sprint again. And that is just very, very bad practice. So if you remove that whole principle from there, the thing is that we set the priorities continuously, right? So every day when people are done with something, they pick up the next item themselves. So the priorities at a much higher level are set by the tech board, right? The committee that decides on where to go, where the direction is. And that's basically where we take our work from. Those are much bigger things, and we break them down. But that's our work as tech, right? And then we decide when to do and who does what, and people basically decide for themselves. So our work always comes when in larger chunks that come off the tech board, and that we work on continuously. So there is no reason to have these sprints. The nice thing is that, so as soon as you start delivering, right, so we deliver continuously and people recognize that. So it is recognized that we do a lot of work and deliver a lot of stuff, which people are happy with, right? As a result, and because we do that continuously, like every day, nobody asks anymore about estimates and whether it fits the sprint or not. That is just sprints become they get in the way, basically. You don't actually really need them, and work just comes off the board of the tech board, which is again, those are the larger chunks, but this is what they do.
Okay, and Xander, there is one more question. Is this okay? This will be the last
one.
Yeah,
it's okay.
It's from Toby. Hi, Toby. We know each other. I might have missed a point because I got a call. He says, what's your view on using different programming languages in the microservices, or how you would say to govern it without stopping innovation?
Well, yes, you can. So simply put, services, everything in our landscape communicates over HTTP or HTTPS mostly, right? So, and the nice thing is, most programming languages by now, I think even COBOL, has found a way to receive HTTP requests or send HTTP requests, right? So that means it's sort of like the arteries of your software. That means you can literally write code in any language and in any platform you'd like, right? So you can write a Java services that runs on Spring Boot that is run in a whatever container on a whatever AWS, and you can run a TypeScript container in Node.js on a Google Cloud, for instance, and they could communicate with each other. The problem is that it's not just the programming languages that you need to have knowledge of, it's also the whole environment, because the environment, the build system, the pipelines, the infrastructure, they're all different, right? That means that, yes, in theory, you can do this. If you're a large company, yes, you probably are doing this because different platforms fit better with different types of features. However, we don't have those large teams. So that means what we do is we chose a stack. It doesn't mean whether it's the best or not. That doesn't really matter, but it's one stack. It's one stack we can do anything with, right? We can write web applications with it. We can write mobile applications with it. We can write services running in Docker containers on a cloud with it. And so our stack being React Native, well, we're moving to React Native, TypeScript, our easy open source framework, and then it's Next and it's Node running in Docker containers on Google Cloud, on GCP, which basically Google Cloud Run, which basically means that there's Kubernetes underneath. We don't care, we don't see it, and we have Mongo databases running in the cloud as well. Right? So that's our stack, and we chose one stack because our team is too small to maintain multiple stacks. If you're a bank, if you're an insurance company, if you're the Dutch tax service, you can probably do this, but not if you're an e-commerce company that always needs to go fast and has a limited set of people, or as managers say, resources available to do stuff. So we chose a single stack. That doesn't mean it's the best choice. It's our choice. For us, it works.
Great. Okay. So, Sander, thank you very much again for joining us today. It was a pleasure to hear your talk, and hopefully we will see you again next year at the Software Architecture Gathering. Yeah, please,
In person,
everyone.
I hope.
Yes, everyone, please, give Sander your feedback when you leave the stage, and enjoy the rest of the conference.